Hola! Today we are going to talk about chapter 5.3, which is all about the representative groups in the periodic table. So you already know from our discussion that elements in the same group, meaning column, up and down, have similar properties. For example, the group 1 elements react with water very, very violently. There are some really awesome examples of this. Remind me to show you some YouTube videos in class. But why do they have similar properties? Well, it's because of the number of valence electrons they have. And remember, the valence electrons are the electrons located in the highest occupied energy level. So if you look at this little picture of a carbon atom, this is the Bohr's planetary model, and it has a whole bunch of electrons here. But for valence electrons, we only want to count the ones on the outermost ring. So if you look at this ring, there's one here and one here. So this specific atom only has 2 valence electrons. There are only 2 electrons in the outermost level. And this is important because the elements in a group have the same number of valence electrons, which result in similar properties. So carbon, silicon, and germanium are all very different elements, but each of them has 4 valence electrons, and because of this, they have very similar properties in terms of reactivity especially. So these similar properties have led to special names for certain groups of electrons. So we've already talked about how the periodic table is grouped into metals, nonmetals, and metalloids, but even within those groups there are smaller groups, and those groups are the alkali metals, alkaline earth metals, the boron, carbon, nitrogen, and oxygen families, the halogens, and the noble gases. So let me show you where each of these things are located. If I do the dual page display here, we'll be able to see alkali metals, which I'm going to do in green, are in the first column, column 1, group 1. Alkaline earths are in group 2, right here. The boron family is over with boron, you guessed it. The carbon family is the next one over, where carbon exists. The nitrogen family is right here. The oxygen family is the column that begins with oxygen. The halogens are the second to last group, group 17, and the noble gases are the very last group, way over here. Now you may remember that in my last video, or in the last section, we talked about this group right here. This group, if you remember, is called the transition metals. And then down here, these are actually called the rare earth metals. Rare earth. We're not going to talk much about these sets of metals because it's actually pretty complicated. So for now, we're just going to stick to these main groups. Alkali metals all the way to noble gases. So let's talk about each of these groups. The alkali metals, as I said, are the metals from lithium to francium in the very first group, group 1. They are all similar because they all have 1 valence electron. And they're very reactive. They're only found in compounds in nature. And it turns out the reactivity increases from the top down. So not only are all of these elements very reactive, francium is the most reactive of them all, with lithium being the least reactive. So as you progress down the group, the reactivity increases. Now the alkaline earth metals occur in the next group over, group 2, and it's beryllium all the way down to radium. And all of these elements have 2 valence electrons. In a pattern, group 2, 2 valence electrons, group 1, 1 valence electron. It turns out that these elements are somewhat reactive, but they're not super reactive, and their reactivity varies. It's not like the alkali metals where the reactivity increases as you go down. The reactivity varies. Calcium, strontium, and barium are all fairly reactive, but magnesium's actually pretty weak. So there's no set pattern of reactivity within this group. Jumping the transition metals, going over to the non-metal side of the periodic table, we find the boron, carbon, nitrogen, and oxygen families respectively. So this is the boron family, and there are more down here that have just been cut off by this picture. The carbon family, the nitrogen family, and the oxygen family. And it turns out that each of these have 3, 4, 5, and 6 valence electrons respectively. So the boron family has 3 valence electrons, carbon family has 4, The nitrogen family has 5, and the oxygen family has 6 valence electrons. And all of these are fairly reactive, but not super duper reactive. And the metallic properties of these increase down the groups. So while we have boron quickly followed by aluminum, which has very metallic properties, as we move over to the oxygen group, as we go down, we have to move farther down to find more metallic properties. But as we move down the groups, they become less nonmetallic and more metallic. Now the halogens are in group 7, and it includes the elements fluorine through astatine. And as you guessed, I'm sure, this group, they all have 7 valence electrons. And they're all very, very reactive. Just like the group 1 alkali metals, the halogens are all very reactive and usually only found in compounds. But it turns out that the pattern is actually backwards here than it was in the group 1 alkali metals, because reactivity lessens down the group. So that means that fluorine is the most reactive and astatine is the least reactive out of these, although they are all very reactive. And finally, the noble gases. The noble gases are in the last group, group 18, and they consist of helium all the way down to radon. These have 8 valence electrons, all except for helium. Helium only has 2. He's kind of a weirdo. But they're all very unreactive. That is something that they have in common. They do not react with other things, and this actually makes them very useful for certain things, such as incandescent light bulbs. So an incandescent light bulb is a light bulb that has a little piece of metal running through it, and that metal gets hot as electricity passes through it, and that's what creates the light. Now the reason that this piece of metal doesn't just burn up and catch on fire is because it's filled with argon. And argon does not react with this hot metal to combust like oxygen would. It actually doesn't react at all, which causes this to stay hot and stay intact for a very, very long time. So noble gases are totally snotty, just like nobles, and they don't like to react with other elements. Now, these varying amounts of reactivity are actually based on the number of valence electrons. So we saw that the group with 1 valence electron and the group with 7 valence electrons were very, very reactive. The group with 8 valence electrons were really unreactive. And this is because elements with a full valence shell are very, very stable. They do not want to gain or lose electrons because they're totally happy. They have a full shell. So the noble gases fit into this category. Their outer valence shell is filled to the brim with 8 electrons, and they do not want to change that number, so they're happy. They're not going to react with anything else. However, elements with almost full or almost empty valence shells are super reactive. So if we look at the elements next to the noble gases, the halogens, they only have 7 electrons. So they have a space for 1 more. And because that space really, really wants to be filled, they react very, very well with other elements to try and fill that space. That's what makes them so reactive. So here are your homework questions. Read them over, answer them the best you can, and have them done for tomorrow.